Welcome back, dear students, to video number 4 for Standard 10, chapter number 3. In the previous class, we discussed that the point of contact of touching circles lies on the line joining their centers. If the circles touch each other externally, distance between their centers is equal to the sum of their radii. The distance between the centers of the circles touching internally is equal to the distance of their radii. Now let us continue with practice set 3.2. Question number 1. Two circles having radii 3.5 centimeters and 4.8 centimeters touch each other internally. Find the distance between their centers. Now over here, the circles are touching each other internally. That means their distance between them would be the difference of their radii. The radii are given to us. Let us start. Let the radii of the two circles be R1 and R2. R1 is 3.5 centimeters and R2 is 4.8 centimeters. This is given information. The two circles are touching each other internally. Therefore, by theorem of touching circles, the centers and the point of contact are collinear. The distance between the centers of the circles touching internally is equal to the difference of their radii. Therefore, distance between their centers is equal to R2 minus R1, which is 4.8 minus 3.5. The answer is 1.3 centimeters. Question number 2. Two circles of radii 5.5 centimeters and 4.2 centimeters touch each other externally. Find the distance between the centers. Now when the circles touch each other externally, we are supposed to add the radii. Solution. Let the radii of the two circles be R1 and R2. R1 is equal to 5.5 centimeters and R2 is equal to 4.2 centimeters. This is given information. The two circles are touching each other externally. Therefore, by theorem of touching circles, the centers and the point of contact are collinear. The distance between the centers of the circles touching externally is equal to the sum of their radii. Therefore, distance between their centers is equal to R1 plus R2, which is equal to 5.5 plus 4.2. The final answer is 9.7 centimeters. In this manner, when the radii are given to you, you can find the distance between their centers. Question number 3. If radii of two circles are 4 cm and 2.8 cm, draw a figure of these circles touching each other, first one externally and second one internally. The first figure which I have over here shows circles touching each other externally. There is a circle with center O whose radius is 4 centimeters, another circle with center P whose radius is 2.8 centimeters. Their point of contact is point A, O dash A dash P. Second circle is circles which touch each other internally. So I have bigger circle with center O, radius OA 4 centimeters, smaller circle with center P, radius PA 2.8 centimeters. Their point of contact is A. Here O dash P dash A. Next, question number 4. In the figure, the circles with centers P and Q touch each other at R. A line passing through R meets circles at A and B respectively. We have to prove that first, segment AP is parallel to segment BQ. Second, triangle APR is similar to triangle RQB. And third one, find angle RQB if angle PAR is 35 degrees. Let us begin with first sub-question, where we have to prove AP parallel to BQ. Now, first thing what I have is, I know that P dash R dash Q by theorem of touching circles. Now, in triangle PAR, in this triangle, segment PA is congruent to segment PR. Both are radii of the same circle. So if these two segments are congruent, that means the angles formed by them, this angle PRA and angle PAR. So angle PAR congruent to angle PRA. The reason? Isosceles triangle theorem, because these two sides are equal. Therefore, the angles are congruent. Similarly, in triangle QRB, this triangle, segment QR is congruent to segment QB, radii of the same circle. Therefore, this angle QRB, is congruent to angle QBR. Again, the reason, isosceles triangle theorem. Now next I have angle PRA. So this angle and angle QRB, this angle, they both are vertically opposite angles. So they are congruent. This angle and this angle, vertically opposite angles, they are congruent. So this statement where I say that angle PAR, so this angle and this angle is congruent, and this angle and this angle is congruent, and this is congruent. So that is my statement 1, statement 2 and statement 3. So from 1, 2 and 3 I get that PAR is congruent to QBR. What was my 1, 2 and 3? This is equal to this. This is equal to this. So and this is equal to this. So from here I can say that this angle PAR is equal to this QBR. That is PAB. I'm taking the whole line now. Instead of R, I'm extending to B, is equal to QBA. So this angle is equal to this angle. And they are alternate angles. Therefore, segment AP is parallel to segment, just a minute. Therefore, segment AP is parallel to segment BQ because they are alternate angles. So, alternate angles test for parallel lines. So, this is how we prove the first sub-question. Now, let us go to second sub-question, where we have to prove the two triangles as similar. Now, in triangle APR, that is this triangle, and triangle Q or RQB, this triangle, we know that PAR is congruent to QRB. from 1 and 3 we can say that. And PRA, this angle, PRA is congruent to QBR. So PRA is congruent to QBR. From 2 and 3 I can say this. So I have two pairs of congruent angles. On the basis of this, I can say that triangle APR is similar to triangle RQB by AA test of similarity. This proves my second sub-question. Now let us go to the third. For third one, I have a given information, and that is angle PAR is given to me as 35 degrees. So from 1, 2 and 3 I can say that angle PRA is equal to angle QRB is equal to angle QBR, and all these are equal to 35 degrees. From where did I get this? From statements 1, 2 and 3, where I have proved those angles as equal or congruent. Now in this particular triangle, angle QRB plus angle QBR plus angle RQB is equal to 180 degrees. These are angles formed by angles in a triangle. So the reason for this would be sum of all angles of a triangle is 180 degrees. From here I know the values of two angles. So let me substitute them. I get 35 degrees plus 35 degrees plus angle RQB is equal to 180 degrees. So by solving this, I get angle RQB as 110 degrees. So this solves my third part of question number 4. Question number 5. In the figure, the circles with center A and B touch each other at E. Line L is a common tangent which touches the circles at C and D respectively. Find the length of segment CD if radii of the circle are 4 centimeters and 6 centimeters. Now before we begin, we have to do a small construction over here. You can see we need to draw a segment AC, that is joint A and C. This is radius 4 centimeters. Join BD, this is radius of another circle 6 centimeters. Draw AM. See this? AM perpendicular to BD such that B dash M dash D. And we have joined AB as well. Now we know that A dash E dash B, this is by theorem of touching circles, and AE is equal to AC. AE is equal to AC, which is equal to 4 centimeters. They are radii of the same circle. Similarly, BE is equal to BD, which is equal to 6 centimeters. Again, radii of the same circle. And angle ACD is equal to angle BDC, which is equal to 90 degrees. This is by tangent theorem. This is my statement number 1. Now, in quadrilateral AMDC, this quadrilateral AMDC, angle ACD, this angle, plus angle CDM, this angle, plus angle AMD, plus angle CAM. These are all angles of a quadrilateral, which is equal to 360 degrees. Reason, sum of all angles of a quadrilateral is 360 degrees. From here I know that excuse me. Yes, from here I know that this angle and this angle all are 90 degrees. So I substitute the values and I get 270 degrees plus angle CAM is equal to 360 degrees. From here I get the value of angle CAM as 90 degrees. Now all my angles are equal to 90 degrees, but my sides are not equal. That means my quadrilateral is a rectangle. So I say that quadrilateral AMDC is a rectangle by definition of a rectangle. And on the basis of this, I can say that AC is equal to DM because they are opposite sides of a rectangle, and AC is 4 centimeters. That means DM is also 4 centimeters. The reason would be opposite sides of rectangle are equal. Next, have a look over here on this particular line. BM plus MD is equal to BD, this entire line. But I know that MD is 4 centimeters and entire BD is 6 centimeters. From here I can find BM. So this is what I have done over here. BM plus MD is equal to BD, and from here I get BM as 2 centimeters. So my BM is 2 centimeters. Now let me find AB. I know that AE is a radius which is 4 centimeters and BE is also a radius and that is 6 centimeters. When I join both, I get the total distance AB, that is 10 centimeters. That is how I have found AB as well. So using this, in this triangle AMB, it's a right angle triangle over here, and I know AB and I know BM. I can find out AM. So by Pythagoras theorem, I have AB square is equal to AM square plus BM square. So from here, I find AM square as 4 root 6 centimeters by taking square root on both sides. And this AM, my dear students, is opposite side to side CD in quadrilateral AMDC. And we know that opposite sides of a rectangle are equal. That means AM is equal to CD and AM is 4 root 6 centimeters. That means CD is also 4 root 6 centimeters. This is your final answer. My dear students, this is all for now. We will meet in the next video. Till then, thank you for watching. Have a nice day.